Okay, there we go.
Well, welcome to the March 18th, 2025 session of TAPR and HamSCI technical session. My name is Dave, KV0S, and this week I did not go to the HamSCI meeting, but I did watch it online, and I've been working on doing some 3D printing and cleaning the ham shack. Um, Michael got me interested in trying to reduce noise in the ham shack. So I've been testing things. And surprisingly, my air conditioner provides a lot of switch mode noise. So I'll have to talk to the repairman to see if I can do anything about it. So that's it for me. Next on the list is Nathaniel, W2NAF.
Thanks, Dave. I went to the HamSci workshop this weekend and helped organize it and run it with my collaborators over at NJIT, and it was very nice to see everyone. I was very happy with how the workshop went. Brought lots of students, got to enjoy talking with lots of people, and I think it went very well. So thank you for everyone who came and participated. It was really nice to see all of you, and for all of you who were at home but come on this call, thank you as well for all of your participation. Back to net.
Very good. Next on the list is Dave, KD0EAG. Go ahead, Dave.
Oh, not a lot to tell. I'm still got a good night's sleep last night after a extended weekend. Extended a little due to weather getting home from uh, Newark, but had a really enjoyed the meeting. So it was well worth it. That's it for me.
Very good. And next on the list is Elmer, N3AGE. Go ahead, Elmer.
Oh, thank you. Yeah, no, I had a great time there at the show. We had the table set up with the antenna, and actually we had some extra things that N6AGN, yeah, Glenn brought along, the polarimeter and things like that. So we had some activity at the table, which was very excellent. I really enjoyed all the presenters that were there. Um, I am now demoted myself to super moron given all the information that was given there. I just every time you think you know something, yeah. But anyway, so that given, I'm back in the shack, and hopefully I'll have another SAS up. And my goal here with Glenn and Robinette is to stabilize. What I want to try doing in the near future is set up a bench test so that I can test preamplifiers and shack boards without going outside with weather and see if I can't do a performance characterization. I know that's a very long reach because I brought that up with a few people and it's a lofty idea, but if I could do a broad source noise and start to develop a way to characterize amplifiers, maybe we can predetermine the quality of amplifiers as they're being built before we install them. And the other part of that is the antenna design, looking at antenna element placement versus Cat5 cable separation for shadowing. I want to do some work on that. So I've been working with Gwen on software to plot receivers that see me or I see them, whatever you want to call it, and see if I can't then characterize uh, patterns based on placement of the antenna because I have a very small antenna surface that I can move around with. But in doing so, one side of the roof is tin facing southwest and the other one's northeast, and see if I can't determine pattern, which would help provide information, let's say. But that said, that's what I'm up against. N3AG clear, back to that.
Yeah. Next on the list is Scott, N5TNL. Go ahead, Scott.
Hey everybody, let's see. This week I asked my future contact to follow up on the Infineon FX10 SDK and eval boards. I spent some time watching the workshop over Zoom, and I tried to work up noise cal constants for the 888 and the various turn island filter options over both the 15 whisper bands and the 10 time standard bands. And I think that's about it for me.
Okay, very good. Next on the list is Bob N5BRG. Go ahead, Bob.
Hello, everybody. I enjoyed listening to some of the talks this weekend and need to go back and catch up on some that conflicted with other things I had going, but it seemed like a pretty good conference. Anyway, that's all I have. Back to you.
Okay. Next on the list is Clint, KA7OEI. Go ahead, Clint.
Not much to add, so I'll just send it right back.
Okay. And then we have Dave Julian, WB9, YIG. Go ahead.
Good evening, folks. Not much going on. Just we had, of course, we had nasty storms here early Saturday morning. About a 5 hour Skywarn net going on. I was playing net control, so that pretty well took out the rest of the day. Getting recovered from that. So we didn't have any damage, but a couple counties over they got quite a bit beat up. So that's about all here. Back to the net.
Okay. Next on the list is David McGaw, N1HAC. Go ahead, David.
Good evening, everyone. Well, getting back to the normal Life's Fire Hose from the workshop fire hose, but great workshop. A lot of really good talks, a lot of good ideas. I've got some things we might discuss for the meter scatter QSO party and how it might dovetail into science. And other than that, I was glad to hear from Bill that it sounds like pretty much his tower got damaged and the boat got damaged, but other than that, they fared okay down there. But up here, we just got what I call the usual flooding. Back to net.
Okay. Next on the list is Bob, WB0VGD. Go ahead, Bob. Mike muted.
Much better. I didn't want to be
Yes.
blabbing away. Nobody could hear me, but maybe that's better anyway. So, no, just been, yeah, we had a bit of a family issue. My brother-in-law was sick over the past few days, so I wasn't able to make the workshop. So I guess I'll watch it, on YouTube and check it out. It sounds like it went well. And I just started experimenting again, sending pseudo-random sequences with my Flex radio in the ionosphere and looking at echoes. So I've been playing with that and developing some signal processing for that and having fun with it. So it's been futzing around, looking at mathematical corrections. I don't have, rubidium clocks and things like that, expensive equipment. So I'm trying to figure out how I can do it on the fly with cheap equipment. And I can mathematically correct for it with my MATLAB script. So having fun with that. So other than that, that's been what I've been up to.
Well, sounds like fun. Yes.
It is.
Let's see. Next on the list is Dave Julian. Did I call on you? Yes, I did. The list jumps around on me, and so Dave Hollister, go ahead. David?
Yeah, that's me today. I don't know why that changed from having my call letters on it. Yep. Hi, everybody. Had a good time listening to the program on Friday and Saturday, and I'm here to learn more. Thanks.
Okay. Next on the list is Franco, K4VZ. Welcome back, Franco.
Hey, thanks. Well, good evening, everyone. This week I've been working actually interesting problem. I'm trying to record samples from an SDR playback, anyhow, from an SDR. And I found out about this format called RF64, which is the next form after WAV files, okay? And apparently allows to store so-called markers. So you can actually mark a specific samples at a specific time. So I was thinking that could be also used to mark PPS samples in, say, RX88 streams or so on. I just read the specs from the ETU as a European standard body that has this format, but it seems to be pretty widespread. So I was reading about that. The other comment, I don't know if you saw, they shut down the Voice of America, so I don't know what's going to
Yes.
happen next. Back to you, David.
Yes, I did hear about that. It's a shame. Next on the list is Jonathan, KC0 EEY. Go ahead. That's KC3 EEY, sorry.
Hi, everybody. I just wanted to congratulate Nathaniel and all involved in the HamSCI workshop. It was a very successful and fruitful workshop. There was a lot of great information. It was also nice to meet some of you guys in the person. I enjoyed our talks that we had, and it was nice to meet Elmer and Glenn and others. Really nice to see everybody, and I had a really good time. Yesterday there were some power outages, and I noticed that the VLF receiver is noisier. Power is restored to everyone at the receiver site, but for whatever reason, it's noisier. And that was like that the last time that there were widespread local power outages in that area, and for whatever reason, the past couple days afterwards, it was very noisy, and then it settled down. I don't understand. There's a lot of things about power lines and VLF that are a mystery to me, and probably a lot of other people too. Power actually went out at my house for about 2 hours. There were some cutoff fuses on a pole down my street that were tripped. So the power company came and they changed that, and my power was restored. But it was neat to kind of see that, because I was watching them change the fuses. So it was neat to see. During the meeting, I also had during the workshop, I had the chance to work on my KiCad, and I was able to do, and I'm sharing my screen. Hopefully everyone sees that. So I had the chance to draw up the schematic for the VLF preamp, and after I was able to find most of the footprint, or most of the symbols online, and the footprints too, from Snap EDA, and they imported okay. One of the symbols I had to modify because the pinout was wrong. That was for the DC to DC converter. Otherwise, everything came out really nice. So the next thing I have to do is I have to define. So for the for the passive components, the diode and the screw terminals. I have to define those footprints because the plan is to make this board all through hole, and the reason for that is for ease of repair. Because often if if something goes wrong, since the circuit is pretty simple, it could be repaired. So yeah, you could see that I was able to but yeah, I was actually quite impressed with how simple it was to use. So now the hard part is to um, uh, do the actual board layout. So I'll be that's the next step, and um, then it'll be one step closer to prototyping and testing. But this is the same circuit that is used in the VLF active antenna that's that we have currently running at Nathaniel's. This is the exact same circuit, so nothing is changed. But other than that, I have two other boards to do as well: the GPS interface board and the VLF receiver interface board. Um, but we're moving forward on that, and I'm happy to see that I could pick up KiCad uh, fairly quickly. That's all I have. Back to the net.
Okay. Next on the list is Michael Howen, AC0G. Go ahead, Michael. Mic muted. There you go.
Hey, everybody. Thanks. Had a great time at HamSCI. Thanks, Nathaniel, and everybody else involved in setting that up. Gary and Perry and everybody. It was a really good and comfortable venue and everything. So, and it was great to see people. I unfortunately didn't get to meet everybody. Unfortunately, I didn't get to spend any time with Jonathan, for instance, and a couple other people I wanted to spend some more time with, but maybe next time. Upon returning home, I found some of there'd been some big weather here, and the single antenna system antennas were up, and the DX engineering antenna was up, but an unrelated beam antenna had lost an element. So I wasn't entirely unscathed, but not nearly as bad as poor Bill Engelke, who lost his whole tower. So hopefully he can recover more quickly. And that's it. Back to that.
Okay. Next on the list is Paul, a WB6 CXC. Go ahead, Paul.
Yeah, good evening, everybody. Yeah, sorry I wasn't able to make it to HamSCI. Sounds like well, I'm really looking forward to seeing the video, those presentations. For me, it's been well, had to travel from California to Washington beginning of the week, but I'm kind of back to normal now. Well, middle of last week actually. So I've been beating my head against the wall on the 6-meter filter preamp, the design rev number 3, trying to get the filter response, and I don't know. I'm still not sure what's going on. But it's really defying my ability to figure it out. But I'm not throwing in the towel yet. Previous version looked pretty good. I made one minor, quote minor change, and now it's just all screwed up. And I cut and jumper my way back to the previous design, and it's still all screwed up. I changed all the components to what they should be. Maybe the GLC put some wrong parts in, and
No, that's not it. So, and the layout's virtually the same. So it's got to be something stupid, or either it or I am being stupid. Other thing I've been working on is this little box there. This is if somebody wants to put a 10 megahertz. It's 5351 processor. It's got a 4-layer board. Takes 10 megahertz reference if you want accuracy, and it will put out 3 clocks at 3 different frequencies. And I got the software to accurately generate those, using integers if you can, and otherwise the best approximation we can get. So I don't know if anybody but me is going to want one of these, but I've got a use for it, so I'm building some of those, and it fits in a nice little case. Of course, there's actually two cuts and jumpers on here. It seems like it takes 3 iterations before I get all that right. This was a really stupid one, but easy to fix. And the other thing I would like to kind of put up for discussion, or at least invite people to, just wondering if anybody else is interested in this recent FCC call for comments on general deregulation, removal of, deletion of requirements. There's a lot of bad things that could happen with that, and a lot of people are, oh, it's Trump and Elon, and I don't give a shit about that. I'm wondering what's this going to mean for the ham bands, and can we use this as an opportunity to maybe eliminate some of the old, 1950s rules and regulations. We've recently had some improvements, the baud rate versus occupied bandwidth thing, and that was wonderful. It still hasn't been applied everywhere, I think just on the HF bands, which is kind of bass backwards. But I'm wondering if there's an opportunity for people like TAPR, people like ARDC, maybe ARRL. I don't know if, they're kind of hidebound, but you never know. Anyway, I invite people to take a look at it. I put up in our meeting chat the link to the FCC document. And if anybody's got comments or wants to start a discussion, I'd be really interested in that. And well, back to you, back to Net.
Okay. And just for you that don't fully know, Paul is our TAPR vice president. So, and he will be a speaker at the TAPR Forum at Friday at Dayton. I will as well. And next on the list is the old man, which I suspect I might know who it is, but go ahead, old man. Mike muted. Oh, not responding. So next on the list is Tom N5EG. Go ahead, Tom.
Oh, good evening, Dave. Good evening to everybody. I want to echo everyone else's comments. The HamSCI conference was really terrific. The Zoom was good. The audio was very, very good. The video was good, done excellently, and the talks were great. So I know a lot of people put in a ton of work and well worth it. Really showed just an outstanding conference, great papers. So that was about it for the week. Other things going on, but back to the group.
Okay. And next on the list is Rob Robinette, AI6VN. Go ahead, Rob.
Good evening, everyone. Yes, I can second or third or everyone's comments about the conference. I agree with Tom. The video and audio quality was superb. I mean, it's almost easier for me with my hearing problems to to understand and follow the presentations on Zoom. And it's pretty much impossible if you're there in person. The delays associated with, video compression, audio compression, make it impossibly sit in the same room and watch Zoom. Uh, I wish I could have come. Um, Lots of things. I've been moving, so I have done relatively little work uh, on my parts of things, but we are refining based upon a comment weeks ago from Phil Erickson. I've been investing quite a bit of time in validating the processing stream. Ideally, you lose every sample of the ADC output sample, makes its way through the whole processing chain without any loss of sample information. And when we started this, there was actually quite a bit of drift, but thanks to that, what would happen is the wave files would start, the first wave file produced would start at second 0 plus 20 milliseconds. But a day or two later, the wave files would start at, well, the worst case, they started, in a day, they'd be off at second 8. So Scott's version 0.9 of his PCM recorder seems to have fixed all those problems. I mean, he reports if there's any lost packets in transmission, IP, RTP, and Phil does what he can in Radio D to report when there's some problems, if CPUs fall behind, and so on. I'm pretty pleased, but I'm not. I don't feel I'm finished because I think for radio science purposes, if we're going to use the RX-888 as a scientific instrument, we need to, tell me if I'm being too, um, anal here, but I think we need to know if there's any samples lost, because in the end, if we want to do phase aligned multi-receiver, multi-antenna receptions, we need to know they need to be synchronized. So this has been an opportunity for me to calibrate the whole receive chain. One thing I've learned is that CPU affinity is very important to this, and the allocation of the different threads, processing threads, to different cores and to different caches uh, is very important. If you don't allocate properly, you do invisibly, so far, you do seem to drop samples or frames or something. I don't know where it's being dropped, but neither Phil nor Scott are reporting any losses, but the files drift and start at later and later times. So um, in the end, of course, it would be great to have a hardware-based timestamp associated with each sample, and then the Phil's driver and Franco's driver could then validate and make sure that nothing was lost in the transmission from the ADC output to the buffer memory in the USB, where the USB transfers go. As far as I can tell, even at 129.6 megasamples on most host CPUs, there's no data loss, and I think that's startling. As long as you put the different processing threads on the right cores. And it's interesting to see how different CPUs are architected. Some of them have, I had never, I knew the concept of layer one, level two, level three caches, but I had never appreciated that, especially in this application, that in Radio D especially at these high data rates, that CPU core affinity is has a dramatic effect upon the reliability of the transfers. So I'm continuing to add instrumentation to Whisper Demon to better monitor what I can, what Whisper Demon can better monitor. I think Franco, I think your driver, I don't know where it would report errors if it fell behind. I don't think there's um, but I would be interested in learning that is to make sure that I look at the radio D logs now, and if they're assigned to the right CPU cores, I don't see any error messages coming out of radio D, which I think it gets some of its error messages from your driver, Franco, and I don't see any. So I think that's really good news. I think, but it would be, it would point out, I think, in the long run, that it would be better if we had in our own design, if we somehow put a timestamp, introduce it between the analog to digital converter and the FX5 or 10 or whatever we choose. Anyway, I could go into that in incredible detail, but that's I already have more than maybe you're interested. So I'll send it back to you if we want to have a discussion
Oh,
on other things. I'll be happy to.
okay. So I think I called on everybody on the list. Anybody that I missed? Then we're open for general discussion.
So
I
I would say, yeah, Rob, thank you for all those updates. And I am definitely interested in discussing some of those things a little bit more. And I do think that it is incredibly important to pay attention to those things. Bill Lyles came up to me at the meeting on Saturday, I think, and he had a plot where he had picked off he had plotted the second tick of WWV starting at the same time for multiple days in a row. And he was able to show that there was a significant drift in where that second tick or where that minute pulse was. And I was wondering if you had seen that and if these corrections that you're making um, do in fact address that issue.
Well, I have been talking with Bill. It's not clear to me. Bill did absolutely identify that when you have multiple bands that you're decoding, right,
Yeah,
at the same time, that they can be decoded. They can be decoded at different. They can be their sample times can be different. But I believe, now I haven't been able, that the offsets are constant. So let's say, 10 megahertz has an offset because we don't know, that PCM record starts recording when the system clock transitions from second 59 to 1. Then after that, okay, the WWV recordings should have exactly the same number of samples. So there's going to be buffering and jitter in terms of when the processing occurs, but
mm-hmm.
but I believe that that the offset should be constant over. I've seen a month and on and
Yeah.
on.
That was
But
not what he showed me. It
okay,
looked like there was some drift where I believe it was on some days it was 20 microseconds. I think on other days it was 60 microseconds. So it was definitely not a constant offset. And so I don't know if he got data from before you were addressing this, or if this is the new data, but it definitely was not a constant offset, and that
well,
was something that I had asked him.
okay, yeah. Well, then there's some. I know that Phil mentioned, I guess he isn't with us. Phil mentioned that he discussed this issue with Bill and
Yeah,
Gwen and others, and Phil was going to try to prioritize the threads.
right.
Uh, uh, I, in my, I don't see the need for that myself. I mean, I don't see how that would. That's processor scheduling is random almost. Yes, you can change the priorities and make, WWV10 the most but if you start process if every wave file contains exactly the same number of samples, and those samples are created by the analog to digital converter that's driven by a GPS DO, okay,
Mm-hmm.
then there shouldn't be any the drift should be the offset of the tone in the wave file should be constant. It will never be it'll never be time zero because there's processing time going on. But
Right.
I don't understand how, if Scott reports that there's no RTP loss,
Mm-hmm.
packet loss, and Phil's log file reports that there's no dropped frames, and
Right.
I never seen a drop frame from
Mm-hmm.
Phil, then what would produce this offset?
Well,
It would change when of course the time when the packets arrive and will be different, but the offset within each of the wave files should be the same.
Mm-hmm.
That's
there's
my
Tom,
there's going
understanding.
there's going to be
Tom
some
and Paul
random
have.
drift. If, for example, you use GPS to clock your ADDs, GPS time will drift around, something on the order of 20, 30 minutes. You're gonna have too many or too few samples because your version of GPS clock is going to differ from the NIST version of clock, just due to GPS and the ionosphere, other delays. So there will be some drift that converges over the long period of time, but it never quite goes to zero, right? There's
Yeah.
always some
Oh,
outlier
yes, of course.
variance.
Well, that's what I'm trying to do next is to instrument the code. Yes, there's the time, there's Linux uh, puts the ext4 file system, surprisingly, records the various times of the file, the create times and so on, to a nanosecond, amazingly. And of course, those times come from the system clock, which is an NTP clock, and it's a terrible clock in general. There's nothing like we would do. But if I would expect that over days, weeks, and so on, that the jitter of the recording time, the file create time, would converge. If you average over long periods of time, NTP keeps the system clock pretty close. It'll be jitter of milliseconds probably, but that's not really important. What's to my mind, what's really important is that we get exactly the same number of samples in each wave file, which we do. We get 720,000 16-bit samples in each wave file. So, and those samples are clocked by the GPS DO oscillator, and that will move. Will it move by milliseconds?
It'll move
So
kind of on the
Paul has
order of
his
50,
hand
100
up, and then
nanosecond.
I
Go
have a
ahead, Paul.
comment.
Right? Yeah.
Paul has his
If I
hand.
might, yeah, let's make sure we're talking about the same thing here. And also, it would be useful to put actual numbers on these various drifts and the sources of these drifts. But Nathaniel, what you were describing with the time variation of the 1 second WWV click or tick, is that the same thing that I think Rob is talking about? I mean, because there will be variation from band to band on the true tick arrival time given propagation. I mean, we're seeing it with Doppler already, and that obviously that means there's a delay, varying delay for Doppler, but even a fixed delay from one band to the other, a different fixed delay will change the arrival time. So if what your friend was showing you was variation in the arrival time of that tick at the receiver, I mean, that's to be expected and can be measured.
Well,
But
this call it
or is it the same? Are we all?
yeah.
Are you talking about what I think Rob's talking about, which is from the input of the ADC to the, to the DSP stage through USB
Yeah.
and all that. So what are we talking about here?
Well, the measurements are being made at the WWV WW0 WWV site. So it's 6 kilometers from the transmit towers. So so I don't
Okay.
think we have I don't think we have uh, transit time differences. There are at times some evidence of
No,
NVIS,
that you're right.
but
That would be relatively
yeah.
insignificant. Okay.
So my understanding of this just this just do a mental theory there. Uh, when Scott starts up, he PCM record waits, sits there processing the IP packets, samples coming in, and looks for the first transition from second 59 to second 0. And so at that point, he starts recording a file, right? The first file at some offset, which varies. It varies on each channel because there's, on most Whisper Demon sites, there's 46 demodulators running. So those demodulators, are scheduled. They're running on one core, so they don't run at the same time. And they're probably the order they run in changes from all the time, constantly. But given that once it starts recording at some offset, okay, a band starts recording, it records 720,000 samples. It doesn't look at the system clock. It just says, I've got 720 cockles, close this file, open the next one. And change and don't look at the system time to get any information, okay, about the timing. Once the first Scott, correct me if but once the first packet is a WAV file is created, after that there's nothing, no looking at the at system clock at all. I mean, what I'm looking at. Okay, so is that right?
Yeah, very, very close. But we added a maximum drift value. If it's off by its variable 2 seconds, it'll resync, and that's adjustable. But I would like to interject. I just pulled up the initial email that you forwarded me today from Bill Wiles, and his graph shows a 20 millisecond offset between 5 and 10 megahertz. He zoomed in on the tick on both of them, and he's saying, why is this one 20 milliseconds off from the other? And I think your explanation of at startup that one linear demodulator thread was one FFT behind, because 20 milliseconds, 50 hertz, that's the pacing rate of the forward and reverse FFTs. So at startup, that 5 megahertz stream will always be 20 milliseconds offset from the 10 megahertz, forever.
Yeah, I mean, it
That's
seems to
why
me,
one of the
it seems to me that you could, okay, uh, uh, maybe. I mean, I don't think it's that important, but you could have PCM record say, okay, I've just got, this is the first, well, maybe it can't be in PCM recorder. It'd have to be in Radio D someplace where you say, okay, I'm processing the first. I've just started up Radio D, and I've just emitting my first packet. Let's make sure that that Radio D, all the threads look at the same samples that are coming out of the same block of FFTs. We don't care when we don't care when the linear demodulators run. That's not a. I mean, ideally they'd of course run right at second 0, 00 nanoseconds, but for our purposes, I don't think that it's that important that that we are synchronous with the wall clock, and I think it's almost impossible to do so, lacking a hardware clock associated with each sample. I don't think you can do it, but I don't think we need it for our studies. I mean, you can tell me if I'm
No,
wrong, but
actually, we do.
you do need
We
absolute
want to be
time.
synchronized to
Well, then we,
the
if you want to,
nanoseconds.
well, if you want it, then you have to, you can't, you have to have the USB stream has to have the GPS clock
Well,
associated with it.
the you have to know when the record was taken. The record can come at any time, but you need to have a proper
No, I
timestamp on
think
it.
Bill Lyles was talking to Phil Karn about this at HamSCI workshop, and I think they were talking about starting to add timestamps to the samples
Right.
somehow.
Yeah.
So I've
Uh,
been
I mean,
working,
you
I've been
can put
working on,
timestamps on every sample, but that is really onerous for the
Or
amount of data.
even some of the
But
samples.
if you
Right.
packetize it and you know the beginning time of each packet,
Right.
that's sufficient. And then if you've got the same number of samples in each packet, you're fine.
so I've been
Couple of
working,
Tom,
logistics on the call here. Nathaniel, you've got something bleeding through like a fan or something.
Oh.
And then
Oh.
Scott, you're overmodulating. You're 10 dB over everybody else. And I was going to say, my comment was that if we've got, if we see drifts in the maybe microsecond range, and your GPS disciplined, you have a positioning error. If you get your position off, it will
yeah.
drift back and forth.
Yeah.
Well,
Tom McDermott had something to add, please.
yeah, so I've been working on an FPGA for the FX10 to accommodate its different internal structure. One of the things that FPGA does is it receives a PPS edge from GPS, and it timestamps all of the different radio channels in the FPGA. Actually, it inverts the MSB, which I think Phil's code can identify. And so that would be once per second that the MSB would be inverted once on each channel. So ideally, you'd have the exact number of samples between PPS edges. In reality, that won't happen because the PPS clock is going to wander slightly compared to the GPS clock over time, but it won't be too much. We're talking nanoseconds or tens of nanoseconds time constant. But I think the IEEE 1588, the White Rabbit stuff, they all timestamp the samples. And I think that's, it's not so difficult to do that these days.
I welcome it. It'd be great. I'm doing what I can, given the architecture of the 888.
By the way, you
And
don't have to reinvent the wheel. There's a NASA data format that they use that does that.
Hey, can I ask a question? Scott talked about resynchronizing if it was off by whatever. What if the resynchronization was, and I'm going to make this statement, I'm going to shoot myself, every time?
I think that's really. If you were to resynchronize on every minute, then you'd be subject to any variations in the system clock. You'd be using your host computer system clock to determine when your wave file recordings start. And I don't think we want to depend upon the accuracy of the system clock. I'm seeing on systems that work well, I'm seeing it looks like, but by inspection, it looks like something like offsets of typically 20 milliseconds, and wave file write create time that varies by plus or minus 10 milliseconds from wave file to wave file. And that seems to me to be, I would guess that difference, if everything else is there's no loss of data in the whole stream, that my inference is that 10 millisecond jitter is the jitter of the NTP implementation in the host clock. But I want to extend the monitoring of these wave file create times and log them over long periods of time. But I have had some of them running, like the Orange Pi at KFS was running for 6 weeks, and it was still at offset 20 milliseconds, plus or minus something. Now that was a 64 megasample configuration. The Orange Pi doesn't run reliably at 128, 129. But uh, I look where for uh, for radio D to report errors. Uh, I look for PCM record to report errors, and they don't report anything going bad. So I assume we have no packet loss. There's no RTP packet loss in transmission. That I think Scott does. I've seen that when I corrupt the network or something. I can see him report that there's sequence number errors in the RTP stream. So I believe that Scott's doing a good job of monitoring that the RTP stream that is being received by and recorded by PCM record is in fact there are no losses from the output of the individual linear demodulators which create those RTP packets. There's no losses from those linears to the wave files. So if there's losses or jitter, well, the jitter I can see could come from the NTP jitter on the Linux system. But that's just wave file create time jitter. It's not. It has no relationship to the sample, the A to D samples. I mean, it's only very distantly related to it. But so if there's any, if you were to lose a second of of samples in the USB transfer process, then it would take an extra second for a PCM record to record. The start time would move by a second. So instead of being in second 0, millisecond 20, it would be at second 1, millisecond 20. So I've never seen that happen anymore. It used to, but it doesn't now. Um, so that's a mental exercise of, but of course we've got 129 million samples per second. So if there were somehow, if one, I think what are the sample block sizes for the USB transfers? I don't know if they were lost. I don't know if, does your driver detect them, Franco? Would it would Phil get a report from you that, oh, we dropped a USB transfer?
No, I don't know if you detect it, but you would definitely see in the data because it's not just one sample. You would lose like 16,000 samples.
Yeah. Well, 16,000 samples it would still be almost invisible. I mean, what is that? It's it's probably.
Okay, so there are some techniques I think that that could be used. I was reading about this experiment that this guy did, and maybe we can try something like this. Let me send you the link, Rob, and see if it's possible. Like with a simple generator, so we can basically try to get rid of. Here, let me send you the link. So apparently, this guy said that with this method is able to detect even a single sample missing, not just 16,000, So I was wondering if he could reproduce this kind of test, which doesn't even require K9Q radio, just recording the samples and see if it's something doable. Maybe something we can think in the next day or two and see if we can make it happen.
Yeah. Okay. Well,
Yeah.
I see Scott had chatted that he's hacked up Radio D uh,
Okay.
to try to take the timestamp and sample count from the USB transfer and carry those through the
Okay.
forward and reverse FFTs into the RTP setter. That would be a good thing.
Yeah.
But of course, the host computer's clock is much more unreliable than the GPS DO.
How
I don't know.
accurate do we have to be? And why can't we, use the second ticks of the WWV signal we're listening to
Well,
make sure we're relatively calibrated? I mean, I know they're going to vary. That's the Doppler shift we're studying. But over time, that variation is going to trend towards zero, right? Um, and
well,
so we should be able to maintain a pretty stable time reference, even
Uh,
with
no,
without a
the
local time source.
WWV coming over HF is not stable.
yeah, yeah.
So
And
from
it
moment to
won't
moment,
trend towards
agreed.
zero because that's, the frequency, the 1 second frequency would trend towards, zero error, but the actual time, the timestamp, if you're using it as a timestamp, that's going to be propagation delay variable.
Yeah. Um, just to put it in, a lot of what we're doing now isn't so time critical maybe, but if we ever do any time of flight measurements at multiple sites, it is very critical.
And
I
also, if we
agree with
want to
that.
do, if we want to phase correlate and associate multiple antennas at a site,
Yes, that too.
we need sample coherence between multiple receivers.
Right.
Rob, I
Well,
was
hopefully,
thinking,
if you have multiple channels, they're sampling at the same time. You have to design for that.
Yeah.
Rob, I was thinking, what if you were to feed the RX-88 with the same generator in input and with what's it called pole device 129 with the SI 5351 as clock, so they would be the same thing. You could definitely tell if a sample is missing or not because they would be exactly the same clock. Makes sense what I'm saying?
Well,
No.
yeah. I mean, but those detections seem to me to have to happen inside the SDR. That's once you need. It seems to me that you need to be sure that you're not dropping. You're getting a sample from each clock cycle. You're getting a sample, and you're not losing it. And
No, I was thinking as a test to see if that could be the case or not.
okay, well, if you can come up with it. I mean, for our current purposes, I think it was that what started me down this path was Phil Erickson asking about sample time accuracy 6 or 7 weeks ago. And then I started noticing that some of the Whisper Demon grape sites, the wave files start times were drifting at Elmer's. They were drifting 6 or 7 or 8 seconds in an hour. So I don't know what we've done to fix all that. I'm not quite sure, but it's no longer the case. Um, Nevertheless, there is some drift. I believe, but I've been doing this by inspection. I wrote a little script that looks at the. I could show you what it looks like, but it looks at the wave files and outputs their create times. And if you have 4 or 5 of them, you can see. You can see that they're generally and most sites there's some jitter, but at now with newest code there is not. I haven't seen any drift. But if you get that, if you drift out of the whisper decode window, then you start not getting you're not decoding many of the whisper signals. So, but that's a gross problem, and Whisper attempts to overcome such imperfections in the sample and recording times. Uh, but looking for the cost as a raise. But I think that it's a couple seconds on a Whisper transmission, minus, 1 second early to 2 seconds late. It'll do a decode. But but we've, I'm eager to see that we have. Um, um, that we understand and try to evolve towards a system that is as scientifically useful as possible. And I think that having Tom, I'm very glad to hear of your work, and I don't know if he's still here. Oh, yes, you are.
Yeah, he
Anyway,
is.
that's great. To my mind, it seems like you have to have an FPGA between the analog to digital converter and the FX5 or 10 or whatever you're using.
Yeah,
And
there's no way to match up the data rates from multiple receivers to the FX10 without an FPGA. So you
yeah,
got to
yeah,
have one there anyway.
yeah. So, so that's one of the several important elements we would want to have from our own our own design. And I'm surprised how much the CPUs and the USB channels don't seem very burdened by these. If we're running at 120 megasamples, the USB processing thread on a contemporary CPU like the Ryzen's or an i7 or i9 or it'll be 30-40% of one core. That's not a lot. I mean, that's at 129 megasamples. So it seems like we have the CPU and the I/O bandwidth to support. Um, yeah, Franco, take care. Thanks for your interest. It's um, anyway, the uh, it seems important to include in our design criteria for whatever for our own receiver. Sounds like you've already done it. Tom has already known about this. I know I've heard you mention it long ago. But
Hey, Rob, is there a system I could set up beyond the three that I got now that we could focus on the issue and not have as many variables to narrow it down? I mean, I'm just throwing out there. Is there a way that I could configure hardware um, that might aid a solution?
I don't think that we need to. I think when I add this logging, which was really easy to do, it's actually the analysis of the logs is going to be the hard part. Uh, but logging the wave file create times is pretty easy to add. And so then I need to write some bash function or something, or an awk script or something to go in and look at those. Right, this will be you'll get a create time for the last probably month, for every month. So after any start event, I would expect then we would then we would want to look at the offset and variation. The offset is, as I say, I don't think is that important for us right now, given what we're studying. But I think that if there's any loss of data, I think that's a real problem that I think is no longer happening. Uh,
Can we change the subject for a second?
yes.
Go ahead.
Okay. So, still relating to the ARCS 888, there is a problem that Mary Lou showed me today, and she said she talked about it with Gwen at the workshop, and she thinks that, and it sounded like they think that this problem is corrected by using the floats instead of ints in K9Q radio, and I wanted to see if um you agreed with with that, and maybe you already know about this, but Mary Lou has what she calls spiders. So this is a
Yeah.
case of spidering
Yeah.
where the amplitude all of a sudden shoots up here, and then you get all of this extra Doppler shift that's going all over the place. And I guess you have some sort of like overflow error that's causing this. And she said that
Yeah.
from talking with either with Gwen or someone that by using the float version of K9Q radio, this would not be a problem.
Yeah. She's got a sample from a year ago. And at that time, we were recording 16-bit samples, and you may recall how uh, Phil thought that was unnecessary to
Mhm.
go to floats, but but he did implement float outputs and float input and recording in PCM record, and we now have floats that uh, pretty much can't over. I don't think there's any possibility of overload because the dynamic range of the 32-bit float, of course, is 300
Much larger.
dB, and the I think the float value of 1.0 in the IQ wave file corresponds with, I think, 1 volt RMS on the SMA input. So the uh, I think that we compensate for the only place where AGC is now being applied is by Phil in the RF analog RF amplifier ahead of the A to D. And Phil compensates for any changes in the gain. He compensates, adjusts the output values, the float values, to compensate for changes. Um, and the so I think that this problem is is gone away since Whisper Demon 331, maybe 3 or 4 months ago. It's still not fully debugged. But I do think the 331 has problems, but there are things like it doesn't auto start properly and things that I think the recordings themselves are quite accurate. And there's no overflow. It would be nice. I was hoping that Bill Engelke and would get together with Phil and Glenn, because Bill is we need these vertical scales to be in decibel, not in linear units.
I talked
And
to him about that, and
yeah,
I think he's understanding what's going on. But what's also important is that if they're doing it in decibels, it has to be with the clearly with the 32-bit floats, because those are the ones, as you already pointed out, that aren't varying. And Phil compensates for with any AGC he does apply prior to the ADC. So he can't retrospectively do it to anything that's using 3.2.3 or using 16-bit
yeah,
integers,
yeah.
because that AGC is jumping all over the place, and it won't be
And there's
accurate. So
yeah,
we need to
yeah.
figure out a way to get that information into the metadata so that when he runs a script against it, he'll know when to apply a dB scale on the y-axis
Well,
rather than
I
just the
mean,
hertz scale.
it's simple. If it's a 16-bit wave file, then you have to all you can do is apply AGC if it's 16-bit, because there's no metadata associated with those old recordings. Okay, there's whether it's Grape 1 or Grape 2 or Whisper Demon 323, those 16-bit recordings, there is AGC, channel gain AGC applied. And that channel gain there's no place, I didn't know at least, where to put the AGC value into the digital RF format. So I didn't, it's not present in those recordings. Uh, but there's no AGC needed, or no metadata about AGC needed in float sample wave files, because there's none applied and there's none needed. The Whisper Daemon sets the channel gain to AGC, turns it off, and sets the gain to 0.
I would beg to differ. We
Yeah.
talked about this before. There's the problem is there needs to be some sort of agreed upon a reference where a signal of 0 dBm is specified in the floats.
You need that, yes, but
It
it
is
will be
not. It has not been. That has not been done.
well. I don't have the tools or even the skills to make that measurement, but I thought that Glenn or you had done such measurements on several triple eights and established that they are that
For,
1 volt
not
RMS.
for float. That was an action item given to you to bring up with Phil as to where 0 dBm would come out.
And Phil's pumped-headed it back and says, I don't have any way to, somebody needs to measure it. Who has a say, calibrated signal generator.
And that's what Bill Engelke says, is that if we do it on one and we assume that the 888s are constant enough across the board, that would probably be enough. And Glenn has sort of said that he's looked at things. I'm not sure exactly how he did it, but he thought that Phil's scaling of things was actually pretty accurate within a dB or so.
Yeah, that's what I recall Glenn saying.
Didn't I do this?
Okay. Good night.
Beg your pardon, Scott? What was that? I didn't hear you.
Did the Bill Engelke float calibration 0 dB 1.0 DRF plotting stuff? Didn't I kind of do that? I'm not calibrated, but I thought I ran through all that. I thought that was a closed issue. Or am I missing something? Sorry.
Not as far as Bill's concerned.
Well, not as far as he's concerned with translating the DRF data into the spectrogram plots that he's posting up on the website.
Okay, let me rephrase the question then. Where does, assuming a single CW signal represented floating in a whole spectrum, where does full scale A to D converter get represented in floating?
I think it's represented with 1.0. Everything. I think that everything below that is minus values. Or the largest float value is 1.0.
So do we have that officially from Phil?
I don't think Phil's the one who knows it. I think it's.
I mean, Phil would have had to write the program to do so. I mean, Phil would be the one to ask. I mean, we could try it out, but I mean, if you would a reading of full scale on the A to D converter come out to, assuming ignoring bandwidth, if you had a hypothetical receiver that was the same bandwidth as the 888, would the peak value right at tickling full scale come out at 1.0 to 9? Would it be bounded by plus and minus 1.0? I don't think anybody has asked Phil that. That, if you know that, then you can go backwards and then do the RF calibration trivially. But unless you know that, then you're just shooting in the dark.
Well, I'm sorry. I would have wished I'd been there at the conference to stimulate this discussion. I'd really like us to come to closure on this so that we can get because if we can come to closure on calibration from RS levels on the SMA input to the sample values inside the wave files. I mean, and then our only problem is the antenna factor. We have to compensate for that. But hopefully we'd try to go all the way to E field and have a way of having these samples values relate to the E field strength out at the antenna.
Would an easily replicated simple signal source help so that everybody has a calibration standard?
Yeah, it would be nice, but I don't think it's hard enough to get people to install a 888. Trying to get them to calibrate their.
Well, I'm thinking that it'd be easy to build.
You could get within better than a dB with precision resistors in the 5351 with a regulated supply.
Yeah, well, I'm thinking even simpler than that if we just used basically a clock oscillator.
But what would be the measurement?
And then a known attenuation and signal,
what would measure the standard?
Network.
Would you use an oscilloscope? I mean, what would be the measuring standard to say that you produced this 1 volt, let's say?
Well, I mean, a scope would be problematic because
Okay, so what's the measurement device? Because we're arguing about calibration, and I
well,
calibration is
okay,
calibration.
so
Well, here's the idea is that we come up with a simple source. And I have HP spectrum analyzer. It has a calibration output that's 300 megahertz minus 20 dB. It gets all its calibration off of it. If we came up with a simple signal source that we could build little circuit board, we could calibrate each one, or we could just check that the calibration is correct and send it out to people.
This little box, am I on? Yes, I am. This little box of mine, just stick a filter and attenuator on the output, and it would, it would be a calibration source. What I'm saying is, yes,
Right.
it's simple. I'm not saying use mine, but if you wanted to have a little simple calibrator that you plugged into the input of the 888, it wouldn't be difficult and it wouldn't be expensive. Now then you've got the coax, you got the antenna, you got any
But you still
preamps
have to
in front of that, and
you have to
you
one
got to
source to
deal with
measure
that.
it, though. You still have to one source to measure it, to say that destination, the meter scope, is a known and
well,
it's
so
traceable.
There are a number of us who have very accurate instruments that we can characterize
yeah,
a little calibration source.
right. It has to be a narrowband instrument, of course. You couldn't just stick a power meter on there and get an answer unless you filtered it already.
Yeah. Well, the thing is that using say, like I say, a HC oscillator, it's coming out clipping. You know exactly what its level out is, to within manufacturing tolerances, but you could easily calibrate one. And then, it would be a pulse train. I mean, it would be a harmonic street. So, you actually would have multiple harmonics if you wanted them. But you could have it at a very well-known level. You stick it into 888 or whatever you're measuring. And you know what the source is, and it wouldn't drift over time, likely.
Well, I would also think that the first step here is to actually measure a couple 888s and see how much variation there is.
That's a good point. Yes,
I mean,
but
888s, I suppose.
that's what this is for, is so that we could send something to a number of people and just check a bunch of them. Of course,
I mean, but we've got
those of us
888s
who
in the
have
hands
more than
of a
one.
number of people right now who presumably already have accurate signal sources. I mean,
right, that too.
I do. I think many of us do.
Any of us,
I'm
like
talking about,
or...
plus or minus half a dB or something, not
right.
not Bureau of Standards accuracy, but good enough, hopefully, for what it is we're trying to do.
Yeah, even to a dB would be useful information.
Yeah,
that's a 10% variation in level.
So how much variability is there
right
in a 888? I mean, I
Paul,
do not know that answer
Paul,
to that
can I
question.
send you 3 of them and I'll overnight them, and then you can count.
Oops.
I think it's not me. I guess you froze, Elmer.
Well, so one thing I've observed is that you can correlate clipping very well easily with seeing artifacts appearing on an 888 when you approach. I mean, I've done the trick of increasing the signal level of, 1/10 of a dB at a time. And the point when you start seeing spectral artifacts is exactly the point when the clip pin on the A to D converter starts to glitch. So also, for what it's worth, the out of the box 888s that I have, between the 1 dB flatness is between 40 megahertz and about a megahertz. So between 1 and 40 megahertz, it's they're flat within about a dB. I don't know what the variation is.
Did you take the also? Did you take the bias T
no,
inductor out
that's
of?
I said out of the box. So
Yeah,
no.
yeah.
So
It might be even
Well,
better
that's
if you.
pretty good if it's within that
right.
out of the box.
If you take the
1
bias
to 40.
if you take the bias T out, that it's about 70 kilohertz to 40 megahertz. You take the bias T inductor out, it's somewhere around that area. That's assuming all the transformers are created equal. One thing I haven't done is I have an extra 888 here, and it'd be trivial to replace the transformer with 2 capacitors, which if you look at the specs of the VGA is absolutely permissible. But I would lose let's see, 6 dB of sensitivity, but it'd probably work down to audio in that case.
Well, that'd be a good test. It'd be nice to have.
Yeah.
I really don't see the point of 888 going down to audio. I mean,
well, we're hoping we could get some VLF through it.
VLF down to how low?
Well, Jonathan wants down to kilohertz.
Yeah, come on.
I'd be happy above 10 kilohertz.
And Glenn says his antenna goes down well below 1 kilohertz.
Right.
Okay.
So since the antennas actually can respond down there, you might as well see if we can pass it.
That'd be
Well,
a great
Jonathan is
experiment.
using a audio sound card as a receiver, not a 888.
Yeah.
Right, but the point being that we've got an antenna that's doing DC to daylight. Might be nice to digitize it.
Yeah, and one it
Yeah,
may
but we
be
don't have
that
to do it with the 888. That's the point. The point is we don't have to do it with the 888.
Well,
you don't have to, but if it comes for free.
Yeah, and I don't know
and-
has anyone actually measured the coupling capacitors that are in the 888 in the path? They're tiny little grains of wheat. But I have pulled the transformer off, and I have some other ideas for the transformers. So finding one that size is a little problematic. But I have wired in a standard dip, so I can change it out.
The hard part would be finding a transformer that went down to audio.
Well, it's not as hard as you think. The transformers we use actually get down to the tens of kilohertz easily.
Right.
And go to like 200, 400 megahertz.
Okay. It doesn't sound like anything from mini circuits.
No,
it is mini circuits.
So I mean, there's this.
Well, but actually, it's very easy. Once we know what we want, it's easy to buy a core and run a few wires through it.
Wow.
I'm gonna say 73. It's getting a little late here, but thank you.
Okay. Well, hopefully this is a useful discussion. This timing accuracy and amplitude accuracy, and
yes,
I
think it is useful. So
okay.
Thank you so much, everyone. I will see you next week, and happy St. Patrick's Day.
Take care.
Thank you.